in the olden days, everybody basically grabbed logs and you would extract metrics out of logs. That was kind of like a thing. You would use some MapReduce type stuff and you would, do some regex and pull out, the number of successful requests out of your logs that would come in. And we knew that wasn't an efficient or good way of doing it. And so this idea of metrics, which has things like gauges and counters and all these other things, would literally just give you a snapshot at request time.
Hey there, welcome to Book Overflow. This is a podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toups. How are you doing, Nathan?
Doing great. Hey, everybody.
Well, as always, make sure to like, comment, subscribe, leave a 5-star review on whatever audio platform you're on. Share the podcast on LinkedIn with your friends and coworkers. If you're a student, share it with your fellow student. If you're a teacher, share it with your students. And it all helps to grow the podcast. And if you're looking for more help with your career personally, you can book a coaching session with either Nathan or I on Leland. The link is in the episode description. And we are excited about today's episode. This is OpenTelemetry. What is I just think of this as the OpenTelemetry book, but it's got a real name.
I think I did a bad job of putting that in the notes. I think it's Mastering OpenTelemetry.
Mastering OpenTelemetry and Observability.
Yes, that's it.
My Kindle decided to be helpful.
Mastering Observability and OpenTelemetry. There we go. It's a mouthful.
Wait. Is it Observability first? I've got OpenTelemetry first.
Then I type it that one.
Okay. I got Mastering OpenTelemetry and Observability, enhancing application infrastructure performance, and avoiding outages.
Yep. That's what I get for typing stuff and not just letting other things do it for me. Okay.
All right. So that's the book this week. We'll give you the author introduction and the book introduction so we can all get on the same page here. So it's written by Steve Flanders. Steve Flanders is a founding member of the Open Census and OpenTelemetry projects and has over a decade of hands-on experience in the monitoring and observability space. As a senior director of engineering at Splunk, a Cisco company, he oversees the Splunk observability platform and overheads Splunk's OpenTelemetry and spearheads Splunk's OpenTelemetry contributions. He was previously instrumental in bringing what is now the Splunk APM product at Omnition and the Log Insight product at VMware. A sought-after speaker and blogger, Steve frequently shares his insights at prominent conferences like KubeCon and on his blog. He holds an MBA from MIT, underscoring his blend of technical acumen, strategic vision, and entrepreneurial spirit. And the book introduction is Discovering the Power of Open Source Observability for Your Enterprise Environment and Mastering OpenTelemetry and Observability, Enhancing Application Infrastructure Performance and Avoiding Outages. Accomplished engineering leader and open source contributor Steve Flanders unlocks the secrets of enterprise application observability with a comprehensive guide to OpenTelemetry, or OTel. Explore how OTel transforms observability, providing a robust toolkit for capturing and analyzing telemetry data across your environment. So we've kind of done a few weeks of more culture stuff or career focused stuff. We're back in the thick of it with a deeply technical book. We read the first half. We read through chapter 5 this week. Give me your thoughts, Nathan. How are you feeling about this?
Yeah, this was a big pendulum swing. I mean, first of all, you couldn't read a book about OpenTelemetry by a more qualified person.
Absolutely.
And I think this has really taken the whole industry by storm. I went through this shift in thinking, and I think that'll be something kind of cool to talk about. Also, I've always called it OTel, and just like you naturally did. And then I just watched a session the other day from like a GopherCon UK, I think. And there was someone who called it OTel. And I was like, I had to do a double take. And apparently there's like
that
a whole...
at all.
I was like, Carter's going to hate this. And that's immediately what I thought. But it's just like with the like kube control versus kube cuddle versus like, there's like for some reason SREs and DevOps folks just want to give the weirdest pronunciations to things. And I think some of it's because we read stuff all day and maybe don't talk to other humans.
Right.
But also just like OTel, really? Tell us in the comments if you like to call it OTel versus OTel. I'm an OTel person myself, but yeah.
Me too.
To get into the general thoughts though, this book is deeply technical. It's also it kind of changes one of the rules that we typically have, which we've been largely avoiding, sort of like frameworks and specific tooling. I think we're going to deviate from this a bit if it has enough of an industry focus. So OpenTelemetry is sort of like, and you'll see the book kind of outlines this really well. Everything was fragmented. Everyone was having different ways of solving this problem. And a consortium kind of came together and said, hey, actually, if we think about it this way, if we structure it this way, we can get past all the madness. And they were correct. Every observability platform, everything from, Datadog to New Relic to all these vendors that are involved have all kind of gathered around OpenTelemetry for the betterment of everybody, right? And so I think that this helps a lot. I've been working with OpenTelemetry for a few years now. And I'd never really gotten into the deep dive of the innards of how things are working or the vision of where things are going. And so I appreciated this book a lot because I was like, oh, that's why it's this way. Or, oh, that's why we're transitioning from this pattern to that pattern, or this thing's getting deprecated. So I think some of this was speaking to me. But I will say, even my eyes would glaze over a little bit in certain parts where I'm like, okay, like I'm reading this for the podcast. I got to get through this. Like I'm not going to skim it. It's a deeply technical book. I think it's like 50%. Oh, here's everything about OpenTelemetry, and 50% deep reference manual, right? Which is not a fun thing to read cover to cover. So yeah.
Yeah, I agree. I wish it had been a little more like Refactoring by Martin Fowler, when it was a little kind of like, here's a scenario without OpenTelemetry. Here's a scenario with, and then as we apply OpenTelemetry, then it turns into this, right? And you're right, it does lean a little too much into like reference manual. I was excited to read this book because I've been doing a lot of this stuff at work. We were not in a place where we had sort of like auto-instrumented metrics for the application. We were just getting kind of whatever you got for free through AWS. But even then, you get it for free with AWS, but you're kind of limited, and you can't use like Prometheus, and which has like the very powerful PromQL query language. Anyhow, so pick this up, excited to read it, and yeah, it's like this weird mix of like too broad and also too focused at times, right? Which, like, I can't fault the book for being that way. I think I was looking a little more for like a how-to guide maybe. And instead this kind of starts with like, okay, how did this project come to be? Where is it going in the future? What does it mean? Like, what is the status of the project? And like, what does it mean if the project is, I don't even remember all the different statuses, but he like mentions like all the different components of OTel, what status each one are in, and how you can know what the status means and how it's changing. And like, it's just at a certain point, I start wondering like, okay, wait, who is this book really for?
Right.
Which is not to say that there aren't good things in this book. I'm learning a lot from this book, but it is kind of like Steve Flanders said, like, I'm going to put everything I possibly know about OTel into a book. And like, yeah, it's a little, all things come back to Made to Stick. And it's a little like that. I think he might be suffering a little from like the curse of knowledge that Made to Stick talks about. He knows so much about OTel.
Yeah.
Right.
It also, this book in style reminds me a lot of the DevOps Handbook, which I think suffered from the same problem. The other thing that I think is worth bringing up is he does make these sort of like fictionalized anecdotes of this one, SRE that's sort of implementing this thing. And it's the reason I bring up DevOps Handbook is the same critique that I gave, which was it's always the rosy path. Like every time it's like, oh, and then there's this like clever way that I've introduced this idea that we just read about in the chapter. I think it would have also been useful to have examples of like the risk of cargo culting, right? Just saying like, hey, I don't know much about OpenTelemetry, but I saw this cool thing at a conference and I'm going to advocate for OpenTelemetry. And it's a disaster because I don't really know what I'm doing. Like those are these cautionary tales, because I've seen this where somebody just like spouts a couple phrases. They don't really understand what instrumentation is, or they maybe don't really understand how difficult actually getting like useful spans, for instance. Now, the world's changed. There's a lot of great auto instrumentation that exists now, and you actually can get pretty far with just using the like well support. And we'll get into the details of what this means, because I think some of these terms that we're using right now is going to be like completely alien to someone who's not used to this. But yeah, categorically, OpenTelemetry solves problems that were not solvable before OpenTelemetry. Like that's a full stop thing. Before we had this focus of, we actually care about context. We care about your metrics and your logs, and your spans, and we'll talk about tracing and stuff. If we can correlate across those, there's actually really interesting questions we can ask that we couldn't ask when they were 3 separate silos. And
right.
That's a really powerful idea. I mean, I remember I was doing all 3 of those things separately, and actually I wasn't. I was doing logs and metrics, which was very common back in like the mid 2010s. When distributed tracing became a thing because of microservices, it changed the entire conversation. And we'll get into all of that. But I think that was my other critique, though, is it's just like, this is a hard one to do. I don't know how I would approach this book either. And so, maybe it is the curse of knowledge. Maybe it's also that there's a version of this that would be good for a general software engineering audience. And this book's maybe a little bit more focused on like an SRE kind of DevOps person, where they're kind of talking inside baseball a little bit. Because I came to the table with a lot of like this context, right? I was nodding my head and going, yeah, I experienced that. I remember that. So,
but then there are also points where it's like trying to explain like what an API or an SDK is.
Yeah.
And I'm a little like, wait, who's reading this book who doesn't understand what an API or an SDK is? It's a little like cracking open refactoring and being like, by the way, if you don't know what a computer is.
Right.
I'm like, right.
Yeah. That's interesting. I hadn't thought about that. Or like getting into like an array is a sorted list of,
right. So it's I'm with you. Obviously this guy is very qualified, Steve Flanders. And there's lots of good stuff in here. I wonder, does anyone do a tech blog, like a Substack on I wonder if anyone's done something kind of like the Phoenix Project, but like essay style. Like instead of having like one giant overarching narrative, if each post is a narrative, but about like one specific thing, like someone implementing OpenTelemetry, or like I wonder if there's like a tech blog that's like kind of purely narrative like that. You know anything like that?
I experimented with a single post like that a while back, like over a year ago, on Functionally Imperative. And I was like, oh yeah, and then I'll write about this more later, and I never did. It's actually kind of fun. I think that I would, first of all, I'd be surprised if no one has done it.
Right.
And secondly, we need more of it. So I think both of those are true statements.
Have you seen anything like that, folks?
Yeah.
All right, well, let's get into it. So I guess we've been talking a lot about OpenTelemetry, OTel, as the Brits call it, apparently. If you're British, let us know. Is that a British thing, or is that just a one guy thing? But okay, so let's talk a bit about this, because you might be hearing all this, being like, I don't even know what OpenTelemetry is. So we have Nathan, you've written here. Did you grab this quote from anywhere, or did ChatGPT generate this? This OpenTelemetry is an open source observability framework.
Yeah, so this was a summary of ideas. So one of the things I want to do a little bit different is that, because this is such a deeply technical book, I think that we're just going to talk about concepts and the concepts that we learned and things that stuck out to us. So this will be a little more free form. I don't think we're going to go chapter 1, chapter 2, things like that.
I think so.
It doesn't make a lot of sense. But I do think for anybody who, like, this book is about mastering OpenTelemetry.
Yes,
we're not going to teach you how to master that in a podcast, a couple of podcasts about it. But what I can do is introduce you, what we can do is introduce you to concepts and talk about, I was thinking that maybe there's these 3 big ones. Like there's the 3 pillars of OpenTelemetry. There's this idea of pipelining. And then there's this, and they kind of talk about core architecture stuff. Again, they make this kind of like big to do about the API layer versus the SDK layer, and collectors, which is an area that, like, I remember when I first learned about collectors and what they did for data pipelining, it kind of like blew my mind a little bit. And so I think maybe it would be good to touch on that. Or have collectors even stuck out to you, Carter? Like, is this one of those, like, have you had an aha moment about how mind blowing these are? Or is this like you look at it and you're like, well, duh, that's how I would do it anyway? So
no, I think there's a lot of great stuff here, and I do have thoughts on collectors.
Yeah, cool.
but yeah, I like all of that. So maybe we just start at the high level, the
Yeah,
30,000
sounds great.
feet, and then
Yeah.
kind of go there. So you've got written here on our notes. You say OpenTelemetry (OTel) is an open source observability framework that standardizes how we generate, collect, and export telemetry data, metrics, logs, and traces. We're going to talk about the three of those in more detail in a sec. From applications and infrastructure, think of it as a universal translator and collector for observability data. Provides a vendor neutral way to instrument your code once and send data to any observability backend. So those are the three pillars. You got your metrics, your logs, and your traces. We're going to talk about those more in detail in a second. But that was really the big revolution with OpenTelemetry is
Yeah.
a standard, is open sourcing the standard and saying we're going to have one way for sending your metrics, logs, and traces to the back end. And then that
Great.
way, you know, you can, it's vendor neutral, so you can swap out, like you said, whether you're using Datadog or New Relic or any of the other observability platforms. And like if you're using something like Grafana for viewing your data and you've got Prometheus as a data source, Prometheus understands all the data that's coming in. Or I think actually what happens, I think OTel translates the data into Prometheus's desired format. I can't remember which way that goes.
Yeah. There's well, it's the spec now is Prometheus compatible. And so
Right.
that's the kind of cool thing about it. And that's the nice thing that they very pragmatically have taken lots of stuff like Jaeger had its own method for doing a bunch of distributed tracing. Well, it turns out that there's a small like translation piece to it, but a lot of the ideas are there.
Right.
And then Jaeger decided to just like deprecate their sort of like special way of doing it and said, oh, we're just going to use OpenTelemetry's structure. Jaeger is still a web interface that allows you to visualize distributed tracing and look at latency and all this other kind of cool stuff. But the big thing that happened for me, and I've gone into several startups with this. Perfect example is Datadog. Love them, hate them. Datadog's
Right.
pretty amazing, but they definitely take advantage of what they call the Hotel California business model, which is that once you check in, you never leave. But one of the things I've saw, it was like a code smell to me, is if the Datadog SDK starts sneaking into your code and you have annotations for Datadog all over the place, it's incredibly useful. But you have the worst vendor lock for your business logic. Step one would be to use inversion of control, right? Have some sort of wrapper around it so that you're instantiating the Datadog whatever, and then inside of your code you have these other things. But even better is to not even have that Datadog stuff in there at all and use OpenTelemetry and shove that into your inversion of control. And now you have what Neil Ford talked about in the evolutionary architecture stuff of like orthogonal coupling, right? So we all agree that we use OpenTelemetry. So there is a coupling in that we're using the same language, but none of us have to care about like which framework we're using in any language and where it's going at the end, right? Like all I do is I instrument my code. I put I measure metrics, I create logs, I annotate my spans with my trace IDs. And if I do all of these things, I have faith that it's going to be gathered up in some collector, and that collector is going to do something that my company cares about, right? And it takes cognitive load off of the developer. Like, it's your responsibility to do those things, but you don't have to think about like, oh, what's the Datadog SDK tell me? Like, what's some special weird incantation that I have to do? And that's a huge, and that was a big change, right? Like, across the board. I had a huge refactoring that we did, and we showed why this was so useful. And we were helping teams get off of the Datadog SDK. We were still shipping to Datadog. We still found a lot of value in Datadog, but we also wanted to have the ability to not have to use Datadog forever if we didn't want to.
Well, and to me, it's such an interesting example of like the victory of the open source software movement in that. I think if you kind of were to like pitch the open source software movement at the beginning, or even as someone who's not familiar with software, you say like, well, there's all this software that people just contribute to for free and anyone can use it. Like, why on earth would you do that? Why would a business ever support that? But then you see the big data or the observability providers like Datadog or New Relic all start conforming to OpenTelemetry, and you're like, why? Why would they do that? Wouldn't they want you locked into their SDK, to their proprietary way of doing things? But when you're competing, when you all conform to the same standard and you're not competing on standards anymore, now you're competing on feature offerings,
Right.
and you're making it easier for people to get into your ecosystem. Like, we, as a team, one of the reasons we had kind of put off observability for a while was because we really didn't want to make that kind of big, scary decision about
Right.
what provider are we going to use. But then OpenTelemetry lowered that barrier. It's like, well, we don't even need to choose a provider. Like, we can just, like, right now we're just using Amazon managed Prometheus and Amazon managed Grafana. And so we're just kind of sending it
That's
there.
awesome, because I had a great success, especially. Are you? So I'm like a little inside baseball. Are you doing a multi-account org, or is it a single account like monolithic AWS account right now?
No, it's a multi-account org.
Sweet. Okay, awesome.
Yeah.
So yeah, that's the cool thing about managed Prometheus and managed Grafana on AWS is that it's natively multi-account. So you can even like look across all these things. And yeah, it's super pragmatic. If you decide later you want to go to Datadog or Grafana Labs or some, CoreLogix or there's all these cool vendors. If you're using OpenTelemetry, you literally just change this the sync with the syncs in your collector, or you could dual ship. That was something we did where we wanted to de-risk, and we continue to use Google Cloud Services, but we also wanted to trial a new vendor, and so we added a new sync to it, and sent to shipped to both places. And
so
it's amazing. It actually gives you a little more. It's like liquidity in the market, right? It's like you have more options.
Optionality
it gives you optionality, and then it also makes the vendors have to be awesome, right? You have choices, and you're not stuck in something, and you have to do some multi-year refactor to do it.
Right. But now that we're in it, now that we are like, okay, we're gathering our metrics through OpenTelemetry, I think we're now looking more seriously like, okay, do we need like a real deal observability provider? And who should we go with? And so, yeah, I think it helps the observability providers compete where they're actually competitive and not maintain their own kind of standards. And then also for them, it helps with switching costs, right? Like, you kind of see the opposite with like AWS versus Azure, where it's kind of like theoretically, have you ever seen anyone do this? Because like, I know one of the big advantages with like Terraform theoretically is that you can make it cloud neutral. I've never seen that actually happen.
I've had deep conversations with other friends of mine that are SREs. Everyone wants this, and I've very rarely, because the thing is that it's basically like saying Linux has driver support for all the major graphics cards or whatever, right? You're like, yeah, kind of, unless you have some proprietary thing. You basically have to make Terraform like multi-cloud. You have to have a module abstraction that kind of abstracts that away. And so it's non-trivial, because you are writing basically like custom drivers, because, yes, both cloud vendors have blob store, but the way that you set up permissions might be slightly different. And so you might have to make like a blob store module. And now you kind of don't get native use of either one. And so, like, there's some thought that goes into it. You can do it. It's a non-zero cost. But technically, yes, if you can describe the work in a way that is API compatible across cloud providers, then great. And most of them, I will say, most of them have some version of key management service, which you have to have. Most of them have blob store. Most of them have some sort of like API cloud gateway type thing, a Kubernetes layer. If you have managed databases, like all of them have kind of a flavor of those things. And so, but perfect example, Google Cloud doesn't have an equivalent to SES. The SES is the simple email service.
Oh, really? Yeah.
Google Cloud's like, yeah, we don't want to be in that business. Go use SendGrid or something, and you're like, okay, well, I guess I can. Okay, and so there's some things that are not one-to-one, or there's no equivalent to DynamoDB, right? Like DynamoDB is like this magic special sauce that AWS has, right?
Right.
Or some of the weird global scale time series databases that Google has. Like you're not going to replace, that with something that a cloud provider natively has. You might have to move to something like CockroachDB or something. There becomes these edge cases where you're like, oh, well, I can't exactly move. Like I almost can. It's like 95% overlap.
It's right. Like I've never and it's so much work. It's so much work to be like, okay, let me abstract all of my Terraform, so I can like swap it out. So if one day in the future we decide to move from one of the cloud providers like AWS to one of the two other options, like it's a little easier. Just kind of like, guys, if you're going to switch cloud providers, it's going to be a nightmare no matter how you do it. OpenTelemetry is like on the other end of that, where it's like, actually, you get a lot of value immediately by just instrumenting your application with the OpenTelemetry SDK and doing everything with the OpenTelemetry configuration. And then it makes it very easy to swap out providers underneath. And so it's like, is it, I don't know. I've never like been like, okay, just give me Datadog and I'm just going to start with Datadog from the ground up. Like I could imagine a scenario where it's easier to do that, like because Datadog wants you to be able to do that, but it's not that much easier than just doing OpenTelemetry. And the benefit you get from not having that vendor lock-in is huge. So
one thing that surprised me, I did not know this detail. So there's this there's the Cloud Native Foundation. It's like anything that goes into like the Kubernetes ecosystem, and OpenTelemetry is a big part of the Kubernetes ecosystem. Though you don't have to use Kubernetes to use OpenTelemetry. That's like a really important distinction. But it's the second most popular project other than Kubernetes in the Cloud Native Foundation.
Oh, interesting.
And so it's this meteoric rise. Because again, it's one of those where like in retrospect, this is the obviously correct answer, the correct approach to taking here. But I remember being very proud about being like, I remember when I really thought about metrics. And so in the olden days, everybody basically grabbed logs and you would extract metrics out of logs. That was kind of like a thing. You would use some MapReduce type stuff and you would, do some regex and pull out, the number of successful requests out of your logs that would come in. And we knew that wasn't an efficient or good way of doing it. And so this idea of metrics, which has things like gauges and counters and all these other things, would literally just give you a snapshot at request time. You would just, with Prometheus, a good example for some like history. Oh, this is a good one. I think it's a good segue. Push versus pull. So this actually comes up in the book. And so for a long time, you would ship your observability data, meaning like you'd use Munin or some of these other tools, and I would point it at something externally. And like as I was like generating logs, I would ship those off to some log endpoint. If you ever heard somebody have like the elk stack, which is like the Elastic, that's Elastic, Logstash, and Kibana. That was like a very popular observability stack that people ran for a long time. Elasticsearch was like full text search. People have used that for all kinds of things, but we'd also use it for logs. And it was like what powered Logstash. Logstash was this way to like very powerfully go through, and then Kibana is this observability piece and has some other dashboards and visualizations and stuff. But you would ship it off to that thing. Companies like Google and Facebook and some of these other places, they were generating so many logs that they would actually cause denial of services on their own services. With the back pressure of trying to ship things off, you can imagine the control flow of like, if the collector got too backed up, it would not accept new traffic and then they wouldn't be able to ship stuff. So they end up scraping. And so Prometheus, if you look at traditional Prometheus stuff, you actually expose a metrics route, and the Prometheus scraper will come in and hit the matrix endpoint and like grab a snapshot. And so whatever frequency that it's pulling in stuff, it's updating its like database, and there's this whole thing here. OpenTelemetry has kind of allows both push and pull. So pull is nice because as the thing is available, it'll go out and find these things. And if you have like Kubernetes, you can have things like service discovery. So things would auto register. Prometheus would then start scraping from it. It's a cool pattern if you have like a Kubernetes environment. But OpenTelemetry, the reason I'm getting back to this is that the collector pattern and the agent pattern that we'll talk about in OpenTelemetry shifted because all of a sudden registering and then scraping really lost its meaning when you got into a world of serverless. So all of a sudden when you had Lambdas that live for, maybe 200 milliseconds and then put themselves away, there's no way for a scraper to come out and like grab that in time. And so they're like, maybe we should ship these off again. So it's like we've gone full circle. And so anyway, I wanted to kind of give this because OpenTelemetry introduces not just the 3 pillars of the types of messages or signals that we're sending, but also there's some really creative ways to gather those signals up and ship them off.
Well, so let's talk about those 3 pillars.
Yeah.
Let's talk about metrics, then logs, and then traces, because I feel like traces is the one that people don't understand as much. Or maybe let's start with logs, just because logs, I think,
everybody gets logs,
if you're in,
right?
if you're in programming, you understand what logs are, right? Logs, you are logging to the console, you are logging information about your system. You should be doing something. You should be doing structured logging, right? So instead of just printing a random line to the console, you should be using a sort of logging library, like Log4j is the big one in Java that is automatically attaching to each log the timestamp, the host it's running on. Lots of information about it.
Exactly.
Make your life a lot easier.
We call those enrichments. So enrichments are the context around it. And so you'll see this too in a structured log. If you have a good log platform, this will let you filter by, let's say if you're running Kubernetes cluster, maybe I want to look for the logs on a particular pod. So I get the pod ID or a particular cluster that I'm running. I can slice and dice by those. I can like log level, these other pieces. And this was huge, right? When you started doing this, it gave you the ability to do structured queries on top of your structured logs. And I think most people who've like spent maybe 5 minutes thinking about it are like, yeah, this is a good thing. This is like a net positive. I think we've all seen those bad logs where you're like, I remember doing some Python data pipelining where like the logger would literally just take whatever came out of standard out. And so it would just like, it would do these multi-line logs, but each one of them would show up as a timestamped reference, and you're like reading it backwards because that was maybe the way it was sorted. And you're reading like a stack trace upside down, and you're like, this is the worst. This is the worst thing ever. Structured logs at least shove all of that multi-line stuff inside of like the message portion, and you can actually like make heads or tails of it.
And so OpenTelemetry supports sending, it has an API and a specification for logging, for sending logs. I will admit, I have not done a ton of work with this. I think a lot of people with logging, you get a lot of pretty robust logging capabilities out of the gate with like AWS. If you're, between, like CloudWatch logs, and then there's log groups and log insights, and they have a pretty decent, it's a proprietary, I think, what do they call it? The CloudWatch Insights query language for searching through your logs. So I have not felt the need to like get this all set up necessarily like the OTel way. Have you ever done that?
Yeah, we ended up having everything go. And again, you can think of it, if you think of the pipelines, you would kind of imagine OpenTelemetry can act as sort of a middleware between your application and then the destination. So you can just say, log to standard out, use structured logs, and then AWS, you'll tell it, okay, anything that's in standard out and standard error, ship off to our logging, the logging system,
right?
CloudWatch, right? And that's fine. That's like totally fine. As soon as you want to start doing special things like, and again, this is where things will come up, and we'll talk about this at the collectors and some of the processes that are inside of this. Let's say you wanted to have a consistent way to filter out personally identifiable information, right? Or maybe there are certain types of logs that you never wanted to have in your long-term system. You actually can, in your collector, you can set these collector side rules that do some sort of like post-processing outside of your service. And a lot of time, good security posture companies will have these filters in the application itself, right? We put, a bunch of asterisks on top of social security numbers or something so it never shows up in logs, right? But you can also do this. The security team, like your DevSecOps folks, can make another rule in the collector that says, hey, even if a programmer makes a mistake, we'll make sure that if it matches this regex, we will, filter it out. And so you can do this for logs too. And we actually did this I did a SOC 2 type 2 compliance thing, and we had a bunch of collector pipelining logic just to like be extra sure that we were handling data properly. You can also do this thing called sampling, though I've not seen this as common with logs in the collectors, but I'm sure you could do it. And I think we'll get into that more with metrics and traces, because those can get really verbose. But again, the other cool thing about OpenTelemetry is that you don't have to have everything go through the collector to use OpenTelemetry, right? It's
Right.
you just need you need a consistent way to annotate things. And I think we'll loop back to logs after we talk about traces, because there's actually an important relationship between the two.
Well, so let's talk about metrics.
Yep.
So metrics, I think, is what people kind of classically think of when they think of like OpenTelemetry. When you think like, okay, we need observability into the application. Again, most applications, like, you're gonna have logs, and it's not very hard once you like ship it to your cloud service. I mean, if you're a lot of places, especially if you're using kind of like a more managed deployment infrastructure, like Elastic Beanstalk is obviously like very old news at this point. But if you were to ship with Elastic Beanstalk, like, they take care of logging for you, right? And then if you're trying to do something a little more advanced, like, logging is kind of like the very first thing that a cloud service is going to help you take care of. Metrics are more complicated. And metrics, I think that's when you start to think like, okay, I'd like to have more observability into the platform. And so you might be thinking like, well, Carter, I get metrics automatically with like AWS, and you get some metrics. Like AWS, for example, if you're using target groups or like with a load balancer, right? AWS will tell you like, okay, these are how many requests were made to the target group, and these are how many, and then this is like how many of those were 500 errors or 400 errors or 200 errors. Like, it always gives you that right out of the box. That's great. What if you want to go lower level? What if you want to understand, okay, how many failures did I get at this particular endpoint? What's the latency on this particular endpoint? We're using GraphQL. I have a lot of thoughts on GraphQL. And GraphQL, if you want to say like, okay, well, what's my most common GraphQL operation? Out of my resolved fields, what are my most common resolved fields? How long are those resolved fields taking? What's the P99, the 99th percentile latency on those fields? That you can't get out of the box with AWS. And that's when you have to start instrumenting your application on its own. Then you can get even further, which is like, what if I want very custom metrics? What if I want to know every single time a customer signs up using a particular promo link, right? Then you've got to start instrumenting your code more explicitly by actually using the OpenTelemetry SDK within the code itself, instead of like a configuration layer. So that's where metrics really come in handy. You get kind of there are kind of three big metrics. You have counters, and counters tend to be what they call monotonically increasing, which is that the value of a counter only ever goes up. And so that can be a little funny if you're looking at it, because like, for example, HTTP requests is a counter. So you want to know like, okay, how many requests is this endpoint getting? But if you look at just that metric, like on its own, it's only ever going to be going up until the system restarts. And you're going to go like, what the freak is going on? Like, I want to know, I got 3 requests these past 10 seconds. And, but I'm seeing that my counter is going, from 3 to 6 to 9 to 12. And that's just how, I don't know. Do we know why, like, the design decision behind that? Because it really freaks me out.
It's interesting. There's always a trade-off in that it basically, if you are able to express it in a way that's like stateful and not eventually consistent, right? Actually atomically the correct value for this. Having the one that just adds up over time makes the query difficulty it makes the query difficulty like very simple. If I look at a span of time, I don't have to do an aggregate lookup. I can actually just say like, what's the total storage used over the last 30 minutes? And then let's say we sample this once a minute, right? So I should have 30 data points, and it tells me the total storage used, and that data should go up, right? Then there's also one where like, if I just record, you can also in metrics just record that an event took place, right? Like I can say that a new signup, right? So I say new signups. Then when I do a query over the last 30 minutes, I say, how many new signups did I have in the last 30 minutes, right? It's going to go back and look at the last 30 minutes and then give me the sum of that. And I'll do that post-processing, right? I will just see, maybe I can see that And you'll see this in a dashboard. Like we'll look at the number of subscriptions that we got on YouTube, right? And so I can slice and dice this by like the number per day, the number
Right,
in the
right.
month. Are we trending up or down? That's, if I ask it just the total number of subscriptions, that's maybe a metric that it keeps. But because you don't want to have to go back and sample every piece of data since the beginning of time to
Right,
get
right.
that. Versus if I want to know the number of subscriptions I got in the last 30 days, the easiest thing to do is just to go and ask for every new subscription metric event and then just sum that up, right?
Right.
Or I could ask it, give me the average signups per day for the last 30 days. And so then it would just tell me, the average amount, maybe that's the people who signed up versus minus the people who, unsubscribed or whatever. But yeah, metrics are important for a lot of things. I mean, in the traditional sense, you'd probably think of it like CPU, right? CPU is an excellent example where you're getting like a percentage. It's going to tell you like 0.8, right? Or 0.1. And that's the actual sample in that moment. That data point is meaningful, right? I had 80% of my CPU is being used at this moment. 100%, 120%, or whatever. I'm actually backed up. These are the kind of things that is meaningful in that case. And but that might also give you like a good example of like, if I look at a moment, I see that it's at 100% CPU utilization. But if I actually look at the last 15 minutes and I see it was a spike versus that it was sustained, a lot of times you're going to end up doing, and this is where like we start getting into a world, if you get into metrics, the more you know about statistics, the better your job will be, because like there are a lot of like P95 plus P50 or versus P50 versus these other things will tell you aspects of your data that are important, right? Like, are a lot of people experiencing long latency? Or is it really that 95% of people are not experiencing long latency, but 5% are experiencing horrible latency, right? Like, and maybe I really I care about that 5%, that, most people are getting sub 200 millisecond responses, but 5% are getting 6-second responses, right? If I look at the average, it looks like everyone's getting second and a half responses. And you're like, well, that's not a meaningful number. Most people are actually experiencing great service, but something's happening where 5% of people are getting 6-second response times, right? Like, that's bad. And so we can trick ourselves with the numbers if we're not careful. And I think it's a whole rabbit hole. Like, we could probably find a book and do some deep studies on like just statistical analysis of your metrics.
Yeah. Well, and that's what's so interesting is that, like with counters, for example, like Prometheus, right? Prometheus expects your counter to be monotonically increasing, for it to always go up. Now, granted, when you like kill a host and stand up a new host, OpenTelemetry isn't going to keep track of what the metric count was on the previous host. It's going to set it to 0. And so, but Prometheus expects that. And so like, if you look at like the graph of your metric, like you'll see it going up and up and up, and then you'll do a deployment and then it goes down. And you're like, what the freak is that about? Prometheus understands that and knows how to handle it. And I don't know what magic it does on the back end, but it does that. I found out though, CloudWatch metrics does not understand that.
Oh, interesting.
Right. And so I had to set up, and we're going to talk a bit about processors and when we talk more about the agent, the collector, but I had to basically say, okay, when exporting to CloudWatch, and I have these kind of dual export pipelines, I say, when you're going to Prometheus, just do it like normal. I say, when you're going to CloudWatch, I have to use this special processor called cumulative to delta, which says, don't ship the cumulative metric, the one that's increasing. Instead, ship the delta between each period. And then that helps CloudWatch, because otherwise, like with CloudWatch, like you want to take a rate. You basically want to say like, okay, how many, what's my error percentage, right? And you do that by per minute or whatever. So you do that by taking a rate, and then of the request, and then the rate of the error, which one of those are errors, and dividing by each other, right? But that rate doesn't understand when those metrics drop. And so you wind up with like this really weird thing where it thinks you had like negative requests per second, because it's just saying like, okay, well, before, like I was at 100, then 200, then 300. So it's doing good. It's like, okay, I understand I have 100 requests per second, but then it dips down to 0 because it reset. And it's like, okay, the past minute we had negative 300 requests per second. You're like, that doesn't make any sense. So you just have to switch. I had to switch it up. So now
That's
I just
fun.
get that steady 100, 100, 100.
See, yeah, metrics become really important, right? So like there's systems level stuff that you might really care about, like you want to avoid out of memory errors, and you see that the average, memory stuff. And then there's also a lot of like what I would call like business logic.
Right,
So,
right.
Well, there's application runtime, which is like, maybe I care about request latency or some of these other things, and it's like good to keep track of this. And then there's like straight up business logic stuff. Like maybe you care about, like a number of signups, or something like this that's actually like a good, useful business thing. And maybe a signup represents the fact that they made it successfully through an entire pipeline or a funnel, right? Like you actually had to get them to do 5 steps to get this, but a sign up is an indication that they actually converted, right?
Right.
Your business team would really appreciate having access to some of this data. And you might even want to do weird correlations with like, user churn or something, like, have our signups gone up, but the amount of time spent on the website goes down, or, like these other kind of pieces that maybe our conversion pipeline is really high, but what we're offering or how we got those people to sign up maybe aren't compelling, right? Like there's stuff that you can overlap between, sort of the business needs and this other stuff. And again, it's so that you can ask questions of the data. Or you could also do like, okay, they get through the signups, but then do they also get an error message? Like, we can even look up that correlating between some other pieces of the application, or if they do it in this particular order of sequence, that causes an error condition, right? Like they use the application in a surprising way. They did the sign up page, but then they hit the back button, and then they signed up again, and now they have an error, right? There might be some weird things that we just hadn't thought about before.
Well, and then, so aside from counters, you've got counters are kind of the big one.
Yep.
You have gauges. Now, gauges are that's reporting just one value, and that value does change. And so, like CPU usage is a great example there,
memory
right?
usage, CPU usage, disk usage, things like that.
Right. You wouldn't want that to be increasing. You just kind of want to know, okay, I want the snapshot of what this was at this moment.
Right.
And then histograms. Histograms are useful for like request latency. So like what that will actually do is it'll bucket out and it will say, okay, so for request latency, you've created these 10 buckets or whatever, which is like 10 seconds, 5 seconds, 3 seconds, 2 seconds, 1 second, half a second, whatever. Right. And then for every request that comes in, it will update those buckets for each request. And so it kind of looks funny because it's like, okay, how many requests were under 10 seconds? And let's say you had 10 requests in the past minute or whatever. I say, okay, so 10 go into that bucket. And then 10 were also under 3 seconds, and 10 were also under 2 seconds, but only 7 were under 1 second. And then 3 were under 500 milliseconds, right? And then that can be really helpful because that helps you determine your P99 latency. And you can figure, okay, how many, my 99th percentile performance, what was that? And you can either explicitly define the buckets, or you can use what do they call it? Exponential bucketing, which it automatically defines the buckets for you.
Oh yeah, it allows you to have it. I think you end up having, yes, you can kind of like, again, slice and dice. And this is the weird thing too. If you know what the shape of your data should look like and you can store it in that format, there's some nice performance efficiencies. A lot of these things can also be kind of converted and aggregated over time, right? You can, if you're actually just grabbing into these individual events in your metrics or doing these other things, and I can turn that into a counter, right? I can turn that into only give me this growing piece, or I can make a histogram out of other pieces. But I think maybe this is something we should bring up too. OpenTelemetry encourages this. This is still how it is. Logs typically go to like a log optimized database, right? So yes, we're doing OpenTelemetry. Yes, it goes through a collector, but you're going to put it into something that's made to like efficiently get data in and out of that system. Metrics as well. Metrics typically has its own sort of like specialized database for this. And those are typically, some very like optimized sort of time series databases. And have you heard about the looks good to me stack, the LGTM stack?
No.
Yeah, I hadn't heard this till recently. It's really funny. It's LGTM is the Grafana cloud. So like they call it looks logs, Grafana, traces, metrics. So
Oh,
LGTM.
interesting.
And but it's a good way of thinking about it regardless of whether you're using Grafana or not. So basically you're gonna have some sort of log store and query system. You're gonna have Grafana would be your the G is Grafana, which is some sort of a dashboarding tool that is gonna, and a dashboarding tool typically will talk to those different database types. Tracing, I think Grafana uses one called Tempo, but there's several other databases that are pretty common. And then like metrics, this would be like Prometheus or Murmur or TempoDB, or there's like a bunch of places that you can like throw sort of metrics data in. And then Grafana is tooled out to query all of these things. You can like grab stuff out of them. And so while we are talking about OpenTelemetry being this one thing, if you look at most of the diagrams, it understands that it's like shipping off to various backends. Like you're not shoving metrics and logs and tracing, which we'll get into in a second, all into like one big database. It's not something like that.
Right.
Not typically. Yeah.
Well, so let's talk about traces.
Yeah.
These are interesting, and I feel like kind of everyone has logs, right? A lot of places are going to have metrics, right? Traces. Traces, I have seen less at all of the companies I have worked at. I've only had traces at one of them.
Well,
And even then that they had like kind of implemented their own in-house solution for it. It was, one of the cloud providers. So
this is the white
traces are
whale. Yeah.
yes, distributed request tracking across services. So this shows the journey of a request through your entire system. They're composed of spans, which what is a span exactly, Nathan?
Yeah. So the fundamental building block is when a request comes in, you we'll start with web servers and stuff, but you can use this for other contexts. But we're going to talk about REST API kind of web API server. When something comes in, it's going to say, do I have a trace ID? And if it doesn't, it'll create a trace ID. And then for the rest of the data flow, it's going to annotate this trace ID typically in the header. And again, we'll talk about REST API. So we'll talk about this like adding stuff into the headers that go between requests. And so a trace ID is basically saying, hey, there's some unit of work end to end, and I'm going to attach a trace ID to this so that we can now start doing traces. But the trace ID by itself doesn't tell us anything. What we really care about are the spans. And a span is, if you've ever seen if you ever done like systems stuff with like pprof or any of the things, if you've looked at flame graphs, you might look at like a function call and then you see all the child function calls and it kind of, it like grows up into this flame. Like it looks like little flames. And so like there's the largest call waiting for all of the little pieces here. And then once all of those return, the span of the function call ends, right? That the span is measuring some unit of time and is measuring all the children that come out of it. And so anytime I do something and then I maybe call another service or I call another request, anyone in that thing can take that trace ID, take the parent span if there is one, and then create a new span. And so what I can do is I can reconstruct the entire path. I can take this whole annotated, nested tree, and I can actually say like, cool, across this distributed system, I understand how the data flowed, where the latencies existed, all these other pieces. And so, yeah, like you can, and it lets you ask questions. And again, it's like, imagine having flame graphs for distributed systems like that. I think that's like the easiest way to think about it.
But this is really valuable in distributed systems, right? Because,
right.
And I remember that when I was at the cloud provider, we had that. And so you could kind of track and see, okay, how long did this request take in each part of the system? It can be helpful in like a monolith environment because it could still like tell you, like you got to go to the database, right? And so it could let you know like, well, how long is the request taking at the database? But as far as traces go, like definitely helpful in a larger, more distributed environment. And maybe that's why you don't see it as much
Yeah,
in in other teams?
I think the pain had gotten so high. And again, if we went back and looked at like some of the like fundamentals of software architecture and some of the other things where they start advocating things like, event-based systems or some of these things, you're just dead in the water if you don't have tracing in place, a distributed tracing. I will still, it's still useful for a single monolith because to have a good example here, I was actually helping a team that was struggling. We actually set up OpenTelemetry and used Datadog as the backend. And there were software engineers who had never seen the visualization of some of these functions ever. And we had found some places where like, because of a misconfigured database, the reason this service was taking over 2 seconds was because it was actually having to retry connecting to like a queue, or no, it was trying to retry to connecting to a database 3 times, always. It would never be successful until the third retry. And it was because there was like a latency race condition problem, but no one had ever seen it. They some people kind of suspected maybe something was going on, but there was no investigation. And we had a picture. We had a picture that we could show people and be like, every time you make a request, it fails twice. It gets it on the third time. Then it goes off and does this thing. And that was just on a single service. Like it wasn't going off and doing other things. They've fixed the bug within like a day. We were able to ship it. It was really kind of crazy that they've been struggling with this for, I think, a couple of years, which is insane. But it was one of those things where like the system was so complex, 2-second latency in this one very complicated pipeline wasn't really noticed, but it actually had a huge impact on available resources and these other things. Where it was really useful though, and this is where OpenTelemetry becomes magic. If you put the trace ID in your metrics, if you put the trace ID in your logs, you now can find associated metrics in logging for a set of traces. And so I actually can then correlate. I can say, okay, something funky is going on in this call. And I look at all the tracing stuff. And then I go, give me the logs that were associated with this. I can do that now, right? Because the trace ID was like associated with this. It's really powerful when it comes to that. Like you just can like dig right in. If you're troubleshooting, trying to figure out production issues, it will absolutely like change the entire way that you think about stuff.
Yeah, I mean, this is huge because when I was at the cloud provider, we couldn't run our application locally. You could do some amount of local testing, but if you were working on a complicated flow and needed to test it kind of end to end, like you just had to have the staging environment, and so they had set up tracing across all of the different services within our kind of division at the company. And it was so critical for debugging because you'd say, okay, send out the request. I have my request ID, right? And then I put it into the system. And I didn't recognize that's what I was working with. But when I was reading through this, I'm like, oh, that's a trace. I was using tracing back then. And yeah, absolutely critical to understand, okay, where's my code? Where's my request going? How is it interacting with my code?
I forgot the name of so AWS has this thing, their distributed state machine. I forgot what it's called. It used to be called, no, so it uses X-ray though. And so there's this distributed state machine where you basically draw out this big DAG and it lets you any step in it. Like you can use Lambdas, you can use Fargate, but anything it's in this like big, kind of state machine workflow thing. And if you didn't have X-ray and you just literally turn on a switch and it auto instruments your tracing, and you can put more spans inside of it, right? If you actually use the SDK, they give you context and you can put more spans inside of it. But even if you don't touch it, it'll at least give you spans at like when the Lambda was called and when it puts itself away and when the next thing comes in. And you could, again, the visualization, if you've never seen what the visualization for distributed tracing looks like, it will blow your mind. Like the first time I saw it, I was like, how can I just look at this? Like it's really cool to think about what the instrumentation is to pull off. And then once you see it and you get to a certain part in any application and you don't have it, there you will get a pull and you'll be like, I want to be a part of making this happen.
Yeah.
Because again, when you need to troubleshoot something or reason about a part of the system, you're like, I know something's wrong, but I don't know where it's wrong. And then you go, why is this thing taking 6 seconds? And you go, oh, it's mostly in this area. Why is it taking that long there? Oh, it's because, and you're like, and then all of a sudden you can just like pinpoint it.
Yeah, it's really, really cool. So maybe let's take a step now. We've talked about kind of, okay, we've got our metrics, our logs, and our tracing. We understand what OpenTelemetry's role in all of that. They've created a standard. They've created a standard, and so that helps you avoid vendor lock-in. So what does the flow kind of look like at this point? So you have your code. You're going to outfit your code with your instrumentation. So you're going to use the OpenTelemetry SDK, right? And OpenTelemetry SDK often works in a way where you can kind of just like inject it almost at the base layer, and it can do like this automatic metric generation for you. And then if you need to be more detailed, like we talked, for example, you want to know if someone signed up with a specific promo code, if someone made it through a user flow. When at my last company, we would do kind of like processing for these, we called them like audience segments. So like basically it was this workflow that would process that would determine which customers had entered a particular audience and which had left it. And so if one of those segments failed, we would emit a metric. So we would know, okay, segments are failing. So you have that. So the OpenTelemetry SDK is going to kind of gather all those things from your application and emit them. And it's going to send them out using what's called the OTLP. That's the OpenTelemetry protocol. And that is then going to send it, and here's where you have options, because that's going to either send it either directly to your kind of backend, your data syncs, right, to your Prometheus or your X-Ray or your Loki for logging, or it can send it to a collector, and the collector then sends it to those backends. But let's talk a bit about the collector. What is the collector doing? Why is it valuable?
Yeah. Collectors are neat. I think anybody who's been in like there's a couple of pieces to this. It can do it does this receive, process, export pattern, right? So again, you can take some of let's say you consistently need to transform, let's say you're collecting logs in a certain structure, but you know you need to transfer them or add some extra annotation, but you don't want maybe the business logic of the team to actually have to worry about that. I can have a process step inside of my collector that kind of like just injects some extra annotation and then ships it off and exports.
Or for me, remember, I had to switch from the cumulative metric to the delta metric.
Exactly. Right. Oh, perfect example. The
collector is handling that.
Exactly. And so what's nice is that you end up getting this ability to make changes to the way that you ship stuff without having to make runtime changes to your application, right? I can even evolve that over time, right? I could have it so that I split that, and maybe for legacy reasons, I need the old version of the logs, but I also want to have the new version and go to a new system, right? The new system expects the logs to have some extra annotations. I can do all that in the collector. I don't have to go out and do a pull request across 15 services. I can have the collectors, maybe it is the central point across 15 services, and it just magically does it, right? Very, very, very cool. The other piece is, I think that if you're in an environment like a Kubernetes, these will very naturally become like what they call like the sidecar pattern, where collectors can sit. Sometimes you can have a collector that sits right there in the pod. That's super, super tight. You can have a collector that sits at what they call a daemon set, which is like sits right there in each host, so that you know that there's a predictable spot on the host that the collector lives. But then there's other patterns and models, like they call it the gateway pattern or the agent pattern. And these have to do with like, maybe you need the collector to absolutely never be down. You never can have loss of records. And so I have a load balancer with like high availability cluster of a collector, and I'm shipping all that stuff off because let's say I have, 10,000 lambdas that are going to spin up and shut down. And I want all those 10,000 lambdas to talk to my collector gateway, right? And this is the patterns that they kind of give you. You have the flexibility, right? In my application runtime, a lot of times it's literally an environment variable that just says, where's the collector? Like, what's the IP address of the URL and the port? And then that's the only like environment change that you have to do to your application.
Yeah, I really like the collector pattern. I like the separation of responsibilities.
Yep.
Your application is responsible for generating the metrics and sending them off, but that's it. It just says, hey,
Yep.
give me the endpoint.
Yep.
Tell me where to put these metrics. And then the collector, like you said, is responsible for what actually happens with those. And so
And
whether that's like you've got your processors, which are modifying the metrics, or my collector, right, is responsible. We send our metrics into two places. We send all of our metrics to Prometheus, but we send a subset of metrics also to CloudWatch so that we can
cool.
alarm on those metrics.
Nice.
But my application knows nothing about that.
Right.
It's the collector that handles all of
The
that.
other thing that's really nice, and they talk about this. I don't have as much experience of doing head-based versus tail-based sampling.
Yeah.
I've always done head-based sampling because it's just easier. Tail-based sampling sounds awesome, but I don't know as much about it. We can kind of talk about this. Sampling becomes a big deal at scale, and you know, if you're an early stage startup or a mid-stage startup, you can probably just eat the cost of accepting all the metrics, accepting all of the traces.
Mm-hmm.
But traces can get pretty big cost over time. And I think Datadog, like that was a big thing that we had to deal with. We started doing sampling. One of the reasons we got OpenTelemetry is that we could pre-process which traces did we actually care about, right? Like we don't need most 200 OK happy path
Right.
traces, right? We really would care about error, anything that has an error in the trace, in the spans, we probably would care about. And so maybe we'd take all of those. But if it was happy path, maybe we'd take 5% of those. Like we want to still know kind of like the behavior of this thing, but maybe we would disregard most of them because it's just too cost prohibitive. Datadog traditionally, things have changed, but Datadog traditionally was just like, no, like just we'll take it all in. You know, we're very cost effective, but they're not at scale. But if I sample, then I get to make that decision myself and then ship off what I want that's meaningful to Datadog, right? And again, this is the beauty of this pattern, is doing this.
Well, that was a lot on OpenTelemetry.
Yeah, maybe you feel like you're mastering OpenTelemetry right now.
I think all the time about how when I graduated college and like you do that dumb thing in your resume where you list all the skills you have and you list like, are you an intermediate? Are you a beginner? Are you an expert or whatever? And I put something dumb like, oh, I'm advanced in Java. And now I have like 10 more years of experience with Java than I did when I first wrote that resume. And I would say I'm a beginner at Java.
That's
right.
funny.
And I feel that way with like OpenTelemetry. It's like I think someone listening to this podcast might be like, oh wow, Carter and Nathan know a lot about OpenTelemetry. I mean, I'd be like, I am a baby when it comes to OpenTelemetry. Like I've successfully instrumented it in an application. I'm proud of that, but like I only just barely understand what's going on here.
Mm-hmm.
But I guess it's good. Keeps you humble, keeps you hungry. Well, why don't we talk about some of our hot takes? We read this book. I mean, give me your hot takes, Nathan. What do you think after reading it, having read the first half of Master OpenTelemetry?
So, and this is still true. I think it's gotten a lot easier to do this, but like when I first started making the transition to OpenTelemetry, you have to really commit to being vendor neutral. It's so easy to just have like your Datadog rep being like, oh man, just put the Datadog SDK, it just works. It's great. And when you're first making this transition to be vendor neutral, it's a little scary. And so like, I will say, I don't know, this book, I guess my hot take here is that like, you still have to commit to this. And you might have some self-doubt on like, am I making the right decision? Am I drinking the Kool-Aid? Because I still feel like, I don't know, anybody who gets excited about OpenTelemetry, you're like, oh, okay, here's an OpenTelemetry guy over here. You know, just like won't shut up about it.
That's all my coworkers right now.
Yeah. OTel, do you know about OTel? Yeah. OTel.
I'm like turning my monitor towards them like, hey guys, look at this. And it's just like the Grafana dashboard like, yeah, Carter, we know. Like
also the book kind of breezes over at this point. Maybe in the second half we'll get to it more, but like statistics and sampling are hard. And I think that's probably the biggest disservice that we see is that they're like, oh yeah, you can sample, or oh yeah, you should, you know, like the way that you do visualizations, and you're like, you can do it wrong very easily. So a lot of people just skip sampling to your own detriment. But like it's that same thing. It's like as soon as you start getting into what the cooler features that OpenTelemetry are, it's non-trivial. It's a lot. It's a very complex beast. As amazing as it is, there's a lot to think about. There's a, to take it on your shoulders. So this book made that more apparent and not less. Just like your expert level Java. Like I read this book and I'm like, I don't know. I thought I knew I thought I knew a lot about OpenTelemetry, and I read in this book and I'm like, I've got so much stuff to learn.
Yeah.
So yeah.
Well, I think with this book, my hot take, this book would be better if it just knew who it was writing to.
Right.
Like, I'll give like a kind of I have a lot of respect for when someone prioritizes and says like, we're going to purposefully ignore this segment of the audience because we are going to write something that's very well crafted for this segment of the audience. I kind of feel that way about Taylor Swift, in that like when she was doing like her big Eras tour, like obviously Taylor Swift super, super hot. And so I was like, you know what? Like I listened to Taylor Swift like a while back, like Love Story and Shake It Off and like, her old like 1989 album. I like that. But her newer stuff I was not familiar with, but she's super, super popular. And so I was like, I'm going to listen to Taylor Swift. I'm going to, this is a cultural phenomenon. I should, be in on it. And I listened to some of her newer stuff and I was just like, this is not for me. Like I am not a 20 something woman. Right. But I was like, you know what? I respect it. Like, I think it's great that Taylor Swift has made something that resonates really, really strongly with a certain segment of the population, even if the cost is that it doesn't resonate strongly with me. And I feel like this book could have learned that lesson from Taylor Swift, where they should have said, you know what? This book is only for software engineers who want to implement OpenTelemetry in their application. Right? Or it's only for site reliability engineers who want to know the nittiest, grittiest details of OpenTelemetry. But instead, you wind up with this weird thing where like there's a whole chapter devoted to explaining kind of like what APIs and SDKs are.
Right.
But then it's getting into like the very lowest levels of like the OpenTelemetry configuration file.
Yeah.
And it's weird. I'm like, I don't know. I think there's like 3 people in the world who this book is perfectly suited for. And I wish that Steve Flanders had just said, I know exactly who I'm writing towards. I'm going to write towards that person, even if it means that other people might feel a little lost, or the opposite, or they might feel like I'm covering too much of the basics. A little more focus here would have been good. But yeah, it's I'm excited to finish it. I'm excited personally to be reading it because I want to know a lot of this stuff. As of yet, as far as who I would recommend it to, maybe let's flip it this week. We got a good transition here. As far as who I recommend this book to, it's tough, but I'd say OpenTelemetry in general, I'd recommend to any senior software engineer who's looking to make a big impact to their project. If you haven't instrumented this stuff already, this is some really, really fertile ground. If you have instrumented this stuff already, find out how it all works, because like I remember that like when I was working with systems that had this in the past, they're like, okay, make a new metric, and I was kind of like, oh my gosh, how do I make a new metric? And that's probably going to be a nightmare. I gotta register the metric somewhere. It's like, no, if you're doing OpenTelemetry, you just register the metric in your code, and then it takes care of it kind of on the back end. If I'd understood OpenTelemetry better, I would have understood that process better. So I would recommend kind of like understanding OpenTelemetry to any senior software engineer. This book in particular, I don't know if it's the best vehicle for understanding
Interesting. Yeah.
OpenTelemetry.
Yeah, that's interesting, because there's the cool thing about OpenTelemetry is this is something that you can very much consume in some YouTube videos from tech conferences, which I will tell you is excellent resources online. Excellent resources of like, because I would much rather see, an SRE from Uber talk about how they transformed, stack tracing by switching to OpenTelemetry. That's like a useful talk, right? Somebody who's a domain expert talks about their struggles, kind of went through false starts, all those kind of things. Blog posts are excellent. There's also, you kind of have to get your hands dirty. And I will tell you, I didn't talk about this, but like in the book, I had it. I mean, I forgot and left it on, and it was like draining my battery. But they have this like, they actually have this like toy like shopping website, fully instrumented with OpenTelemetry and collectors, and it's literally just like a single make run kind of command. You download their repo and make run, and you have Docker set up. You can run a local environment and kind of see how all the metrics and stuff work. And you got to spend time with it, right? Like these books are great. You're not going to be able to read this book and just like go do it. You need to go like get a collector set up and play with some processes and make some custom metrics and go visualize some traces. Like you need to wrap your head around it to really kind of be like, have that aha moment, right? Now, if you're like, why does it work like this? Or what's the vision? Or what other cool things can I do? This book really is, I think the audience really is SRE and platform engineers. I think that if there was a focus, I think that yes, senior staff kind of software engineer would get a lot out of this book if they really want to deep dive, or maybe you're in a company that doesn't really have SREs as like a real discipline, and you kind of take on some of that stuff on your shoulders and you want to be a domain expert. Like there's also a ton of resources. Like even if you just use this as a reference book, it has like a ton of links to additional reading, additional websites. I didn't click all of them, but I clicked a decent amount and I was familiar with a decent amount. And so like if you just need like a well-organized thing and your company's going to pay for the book, go for it. You know, like I think that would be like the sweet spot, is to be like, oh, I have the authoritative text by one of the people who wrote the spec. You know, it's not a bad thing to have.
Well, what are you going to do differently in your career, Nathan, having read the first half of this book?
Yeah, you know, reading the book, I realized that like I only had a sort of like tip of the iceberg understanding of the collector processing stuff. There's like a ton of things you can do inside of the collector that I haven't spent the time to like poke around with. And so I want to master collector pipelining. So I think I'm going to use that toy app and start start playing around with like weird things I could do with the collector, just so I can like kick the tires and see like, oh, can I do something funky? Can I do, you know, really weird mad science experiments? What about you?
Yeah, I want to look into traces more. I don't know if it makes sense for us at this scale, but it's funny. I've been so proud to get OpenTelemetry set up for our application, and we have a lot of automatic metrics flowing in. But like in some ways, it's just like given us more insight to our pain without knowing how to necessarily resolve the pain. Like someone will be like, the website's slow, and I can open the dashboard and be like, I can confirm the website is slow, right? Like, you know, our latency has gone up. Why is it slow? That's anyone's guess, right? And it's like traces might be really helpful there.
Oh yeah, because you could absolutely hit that, you know, that GET request on the root URL and then just be like, well, what's the graph telling us? Yeah.
So I need to figure out, now that we've kind of got it in OpenTelemetry, and if we were to send it like AWS X-Ray, like how much of a lift is this? I don't know. I need to play around with it. Yeah.
I bet it's both more and less than you'll think it is.
Right. Right. That was my experience with metrics. So we'll see.
X-Ray is kind of magical, and it is cool that it talks OTel. So if you don't want to get a, you know, Jaeger or some, you know, or some of the other visualization stuff, it's really nice. I think you could probably get a lot of mileage with X-Ray. Now, pricing wise and all the other stuff, that's the other part of this equation. You're like, oh, is our AWS bill going to explode because of what we're doing?
Right. Well, we'll find out.
Nice.
Thanks for tuning in, everyone. We'll be back next week. We'll finish up the book next week. And yeah, thanks for sticking around. You can always email us at contact@bookoverflow.io. You can find the podcast on Twitter @BookOverflowPod. You can find me on Twitter @Carter Morgan, and you find Nathan and his newsletter Functionally Imperative at functionallyimperative.com. Thanks for sticking around, and we'll see you next week, folks.
See ya.